Hello again. To those that had joined a while ago, but I see a few more people have joined for the plotting and programming in Python training course. My name is Michael Bareford from EPCC. I'll be leading the course today. So this one, I just want to have a handle on how much preparatory work people have done. I think the first part of this course will cover setting up an Anaconda environment, whether you're in Windows or Linux or Mac OS, and how to then start a Jupyter Lab session within your browser. So I think, yeah, quite a few people have. There's 17 participants, so over half of the people who are logged in currently have.
Excuse me.
Yes?
Yeah. Why do I have to set up Anaconda if I can use the terminal to do Python?
So which operating system are you using? Is it Windows?
Ubuntu?
Ubuntu.
Yeah.
Okay, so that's basically a Linux environment. So I'll go over that in the first part of the course. So you'll need to, I don't know if you have Python installed at the moment.
Yeah, I've got Python installed, but I just don't have.
But you've not installed Anaconda.
Yeah.
Okay, so that will probably involve having to install a package or to download a distribution, and I think there's a link in the notes. So you would do that, and then I think you'll be able to run an Anaconda UI, and within that UI you would then be able to instantiate a Jupyter Lab server.
Yeah, my question is, why do I need Anaconda if I can already run it on terminal?
Okay, so the reason is, it's just Anaconda will, it's a distribution of Python packages, and Anaconda will have the packages required to run Jupyter Lab. So sorry, there was a bit of noise there. So Anaconda will automatically have the packages required to run Jupyter Lab server, and that's the environment within which you can edit your Jupyter Lab notebooks and do things like plotting and do a bit of markdown if you need to, and so on. So that's why we ask users to install Anaconda.
Okay, thank you.
Okay. Okay, so I see that, most people, 13 people have been able to set up a Jupyter Lab environment, so that's good. That can be a part of the course. That takes a while for people to get started on, and obviously it is crucial in order to be able to do the rest of the exercises. So I'm going to close this now, this poll question, and I'm going to start the talk now. I think we've got not quite over 20 participants. I'm going to check the okay, so that was from before. So I start the course now as we're 5 minutes past the hour. So this is the plotting and programming with Python. So here you go. So hopefully you can see this okay. Just checking the chat. So now you should see my a window within my browser entitled Plotting and Programming in Python. So if you can't see, if the font's a bit too small, if you let me know, and then I can just make the font larger. I think everyone's okay with that. So I'll just go to the lesson plan for the day. So what we have, basically we have 4 sets of sessions. We've got one before the morning coffee, one before lunch, and then one after lunch, and then one after an afternoon break for the coffee. And each of these sessions will be focused on a particular part of Python, and hopefully we'll not only explain the rudiments of Python, how to set up variables, how to set up functions and so on, but also how to use packages for to be able to process the data that you might have, to be able to do plots that you would then put into papers or into a talk or anything like that. So each section, each chapter will go through some aspects of Python, show some examples, and then we'll lead with some. We'll end that with some exercises too. So that'll be a time where you can just work on your own, and then if you have any problems with exercises, if you can let us know, and we can either talk about it in the chat or we can take it into a breakout room. So the first thing is to making sure that we're set up okay. And in this part, there's instructions depending on the operating system that you're using. Windows, which most of you are in, that's the operating system you have. I suppose most of you have been through this already, where you download a package, and then you can start your Anaconda environment. And then you have the same thing for Mac OS, and then also for Linux operating system too. So I'm using Mac OS. So what I think I'll do is I'll just show you how to get things started. And so if you've installed Anaconda, you can do things from the command line, just like this. So I've installed Anaconda. Well, actually, where I'm in my home folder. I've installed Anaconda here in Ops Anaconda 3. So that's one point to mention. We are using the Python version 3. So it's Anaconda 3 you'll need to install, not Anaconda 2. But I think Anaconda 2 and Python 2 have been phased out now, and nearly everyone's using Python 3. So anyway, there will be a script in the bin folder called activate, and you can just do that. And once it's activated, you can then run the Jupyter Lab, and that should automatically produce a tab in the. That should at some point. I'll just see what it's doing. Yeah, so that's opened up a tab in the browser I'm using. And so what I've got here is some Jupyter notebooks that I've done before, and here's one actually that is already opened up. So that's the sort of thing you should see. There's another way to start Jupyter Lab, which is a bit more, it's a bit more visual. You don't have to use the command line, but to go back to my terminal window, this is the Jupyter Lab server that I started. I just do a Control-C to stop it, and then it will shut down. Then I can do Conda deactivate to close down my Anaconda environment. That's one way of doing things. You can start things through the terminal window. I can also start things through the Anaconda UI, which I'm doing here. So actually, it's just starting. So here's my Anaconda navigator, and it contains a number of panels for other software environments. So I've also got Jupyter Lab, that's the main of the Jupyter Lab environment, but I've also got ones for RStudio and for VS Studio. But the one I want is Jupyter Lab, so I'll launch that from there. So this is doing the same thing as I've done before, but I'm just not having to type in any commands. So this will do the same thing. It will call up will start a tab in my browser window. And I've got the same type of environment here. I'll just check if there's any questions. Okay, so is everyone able to get to into this part? Are they able to bring up a Jupyter Lab UI within a tab of their browser? If anyone can't, you just let me know in the chat, or if you raise your hand. Okay, so I'm not hearing anything from anyone, so I assume that everyone. How do I bring up Jupyter Lab? So if you're using a Windows OS, when you installed Anaconda, do you have an Anaconda icon to click on using Linux? Okay. So I take it you downloaded Anaconda. So have you installed Anaconda? Do you know where you've installed it? Okay. So have you just downloaded the file? Followed the instructions, okay? Yeah, so there's a message from Andy to say if you go to a terminal window, if it has been installed, then you should just be able to type Jupyter Space Lab. Does that work for you, Lee? Okay, so I assume then when you type that, it says command not found. Okay, so I think what Andy is going to do is just going to move you into the breakout room, and it will help you to get Anaconda to run and to be able to so that you can run your the Jupyter Lab. But I assume that everyone else is okay. Okay, so that's right. So in the meantime, while Lee is being helped, I'll start the next part of the course, which is how to actually, I mean, it's what we've already just touched on, and this is how to start a Jupyter notebook within Jupyter Lab. What this allows you to do is basically to set up an integrated development environment to be able to write your Python scripts or Python notebooks. It allows you to edit small blocks of code and to be able to annotate them too. So we'll just go about talk about how to start the Jupyter Lab, which we've already done. Just going past here. So this is a bit we already saw when I ran Anaconda within my Mac OS environment. And we can talk about the Jupyter Lab interface. You've got basically three areas. So I hope you can see my mouse pointer. So you've got the menu up at the top, which allows you to start new tabs within the Jupyter Lab environment. So if you want to start a console, or if you want to start a terminal window, or a new notebook, or maybe a markdown file, or a text file, you can do that here. So if I want to start a new notebook, I'd have one here. It can be a little bit awkward as you may get confused with the top level menu for the browser that you are using. I think things are a bit clearer here because I've enlarged the font. So that's the first part of the Jupyter Lab user interface. The next part is you've got a browser of your local file system. So within here, I'm in my home area, and then I'm in a folder called, I'm in a training area, and then I'm in the actual folder with a name that matches the title of the course, or near enough. And within this place, within this folder, I have all of my notebooks. And also there's a data folder where I have some comma separated variable files. And these are data files that we will be working on over the course exercises. So I'll just scroll down here. There was a bit about that you can rearrange the user interface. So if I just explain what that means. So this is the third part of the UI. This is where you do most of your work. And if you wanted to, you can rearrange how these tabs appear. So at the moment, I've just got them in a list. But if I wanted to split the screen, I can move my mouse pointer over here, say over one of the tabs of the Python notebooks, and move it down, and you can see that there's a highlighted area in pale blue. And if I have it so that it runs horizontally across the screen, and I let go, and you can see I've rearranged the positioning of the tabs. So this might be a useful thing to do if one of the tabs is maybe an input file that you want to read, and as you are writing your Python code that reads the file, you need to be aware of the format that data exists in. Or it might be a plot. Up here you might have an image in this part, and you're just seeing that you're changing the way the plot is being done, and you're making sure that the changes you make to the plot are as expected. So it's quite flexible, this third part of the Jupyter Lab UI, and that you can rearrange your notebooks exactly as you want them. So yeah, this is just some more stuff about the Jupyter Lab interface. There's a concept here called Jupyter Lab Kernels, and so there was a question here. I think I just heard something through my headphones. I thought it was someone. So a kernel is like a programming environment. So Jupyter Lab isn't tied to Python exactly. You can run a kernel from here. So if I selected new, you can do things potentially. You can have other options in here. So I might be able to, if I wanted to start a notebook, I think it would ask me what kernel I wanted to run. So I'm going to select that. I'm going to have a Python 3 kernel, but it might have been an R kernel. So I'm running R, which is a statistical language, a language for doing statistics, or it could have been Fortran, or anything like that. So I'll just no kernel, I'll just close that and discard. And then yeah, it's talking about the left sidebar. So this is where you would have access to the files within your local file system, and then the main work area. So the other thing we need to check, I think the first exercise here is we're going to open up a data file. Let's see if there's one. So we've got an exercise down here. So I take it everyone has downloaded the data archive that contains, this is the thing. So it's something called Gapminder. Has anyone not downloaded these data files? Okay, so I think everyone has. So what these are is a sort of data files that track the GDP of countries all over the world over a particular time span. So I think every 5 years from the 1970s, or I think from before that, actually, from just after the Second World War, from the 1950s. So someone's asking where I can download that data, so I'll show you. So that will be in, this is here. So if you go to the very front page, the first page of the Plotting and Programming in Python course, where you have the schedule, there's a link here. Yeah, thanks, Andy. You should put the link in the chat too, but there's a link here called Python Novice Gapminder -data.zip. Yeah, so if you download that and unpack it, and if it's anywhere within your local file system, when you go into your Jupyter Lab UI, you should be able to find it here. So I can start, this is in my home area, for example, and I get to my training area. That's where I've got it. So all these, I can't make that large enough. That's an interesting thing. If you want to make things larger, you can change the extents of each of the panels in the Jupyter Lab interface, as I've just done there, in order to reveal the names of the individual CSV files that are in the archive. You can see they're separated by the continents. Oceania is a bit misleading in that it actually just contains data for Australia and New Zealand. But I guess all of the other island states would have been very small in terms of GDP, certainly. And there's one which brings all of the data from all the continents in the same file. As I said, during the exercises, we'll be working on those data files. Close this. So the Jupyter Notebook itself, when you create them, is stored in a JSON file format. Just checking in the chat that there's a message from Andy. Yeah, so Andy's just saying that the data has to be in a directory from the location when you start a Jupyter Lab. Okay, so you won't be able to navigate to it. I seem to be able to go to anywhere on my local file system within Jupyter Lab. Okay. Because thanks Andy, that's something to be aware of then. So when you open, let me start a new one. So you've got in here, I've got a Jupyter Lab notebook that I've opened up, and I would have done that through the File New menu notebook here. And so underneath, it stored things in a JSON file format. So I think I might have a snippet of code here, say, and then I can then add another snippet of code. So each of these things will be installed in a separate part of the JSON file. So we've got our first exercise, which is we're going to arrange the documents into panels of tabs. So this is just a bit of, we'll gain some familiarity with the Jupyter Lab user interface. So first we create a text file, then we create a Python console, and then a terminal window, and we can arrange the panels into the main area, into the main work area, in the manner that's shown here. And then if you want to, you can just play a bit further with that as well. So if you want to just do that, I mean, it's a chance for us to check that your Jupyter Lab setup is working as expected. So I'll leave you to do that for a minute or two. Obviously, if you have any, if there's any points you need to raise, just raise your hand or post in the chat. Hello? So you have there's a question from Hello. Helen, are you able to hear me?
Christ. Hello, can you hear me now?
Yeah, I can hear you.
I'm not exactly clear on what we're supposed to be doing at the moment. Are there some instructions somewhere that I can refer to?
Yes, so there's instructions here. What's the best thing I can do? I'll post this link. So are you able to see the chat? I think Andy's also done it. So there's a link there that starts softwarecarpentry.github.io Python hyphen.
How do I open the chat window?
Okay, there's a speech, and there's a.
Okay, I found it.
The speech bubble. So you found that.
So the link is in the chat window. Okay.
So if you click on that link, that should take you to well,
okay,
take you to the page.
Yep.
So there's a number of. So if you go down to the schedule part of that page, we're on the part 1. How can I run Python programs? So if you scroll down there.
Okay, I see.
The part that we're on.
Yeah.
It's just the first exercise.
Okay. Yeah.
Which is arranging documents. Yeah. So that's quite a simple thing to do. That's fine. I guess that everyone else is fine with this. So I'll move on to talk about a bit about the different modes. There's 2 modes that the notebook can be in, which is a command or an edit mode. So if I just show you again the notebook. Sorry, excuse the noise. So each of these things is a panel. So you've got that's like a snippet of code, or which can either be in code mode, where actually you can type in code if you want, or you can say, and then you'll see that it's indicated that it's in code mode because the outline is in a blue color. But when you click in escape, you're now in a command mode. You can see that the border is now in a gray shade. So what you can do, so a typical command you might do is if you press X, say the letter X on your keyboard, to delete that particular piece of code. So that's gone. And so now I've activated this part of the notebook, so he's now in code mode. If I go to escape again, if I wanted to add another part of the notebook which is going to receive more code, I could type in B, and so there's a new section that's appeared down here. And there's a few other codes that you can type in, or commands. So there's the A key to move you to the code part that's just above you, or the code cell, and X, as we said, to do deletion. So the iris.c, that's just so we're going here. That's just an example. So what you're seeing there is not the actual exercise. That's just an example screenshot of a Jupyter notebook that happens to be opening a data file called iris.csv. So this is just a screenshot. It's not the actual exercise that I was referring to. And in the actual exercise, the one entitled Arranging Documents into Panels of Tabs, these are just examples of documents that you might have. So the kind of thing, yeah, that's fine. So what you can do here is you can just select new, and then you can what you can do is create a terminal tab or a text file or a notebook, and then you can start to do things, and you can rearrange things if you want, like that. So I can do like a vertical split and so on. So back to this, I was talking about how each of the code cells, and these are the code cells, can be in two modes, either command mode or an edit mode. And you press escape normally. If you're in a code mode in one of the cells, you can just press the escape key to go into command mode, and then you can use single letter commands to actually start to manipulate cells. So you can delete cells or create cells either above where you are or below. So this is just to do another exercise is in the Jupyter Notebook page that you're currently in. Do you know, is it in command or edit mode? And then you're asked to switch between the modes and use the shortcuts to generate new cells and so on. I'll give people a few minutes to do this to check that they can do that. Is everyone able to manipulate the code cells in their Python notebook? Is anyone having any problems? Okay, so I think everyone is okay. So I can move on, which is to the next point that notebooks can also render something called Markdown. And what? So there's a question from Andy saying he's not able to get to where I will type code. Okay, so I take it that you're able to open your, you do have a Jupyter Lab interface that's active, is that right? Are you able to see that? Are you able to see the Jupyter Lab menu up here? And can you select the file menu? So this is all, I mean, I'll start again, I'll close all of these windows here. So where you should be is, you should have started a Jupyter Lab user interface within a tab of your browser window. And once you've done that, you should be able to select the Jupyter Lab menu here and select File, New, and then select Notebook. And then you'll be asked to, for the what's known as the kernel, and you want to run Python 3. So just select that, just click Select, and you should be here. And the first thing you should have is an empty cell window within which you can type Python code. So Andy, I take it you're not able to get to the code cell, but just wish to know whereabouts up to you are. I mean, are you able to run Jupyter Lab?
Sorry, can you hear me?
Yes, I can hear you.
Please, actually, I just opened, I installed the app, then open account, but I didn't know exactly where I can get to where you are.
Okay. Okay. So it sounds like that have you installed Anaconda?
Yes, I installed, and
Are you using a Windows system or you've been to
Windows system?
Windows. So if you installed Anaconda, have you run Anaconda?
Yes.
Okay. So once you run Anaconda, can you type Jupyter Lab from a terminal prompt, or is there an Anaconda UI within which you can select Jupyter Lab?
Sorry,
so I'm showing you.
Okay.
So within your, well, perhaps the easiest thing is that within your Windows system, is there an Anaconda UI that you can run, like a user interface? Is there anything like this? that I'm showing you now. Is there due to lab tab that you can click on?
Okay, let me type it. I'm trying to type it in where it says search. Is that?
So you're typing it into a terminal window.
Yes.
Right. Actually.
Because I just opened the app, so it appeared. Then there's a place there's search,
okay.
So you have to like search for, I don't know, but I can see other things. I've not seen that particular one.
Yeah.
Okay.
So I think it's somewhere. So if you could go. I mean, I think what Andy will do is he'll take you into a breakout room and then be able to work on that one-on-one. So that'd be the easiest thing to do. But your answer, whatever it is you want to do, will be explained in the video, which you can play here. That's under the Windows tab in the setup part of the training course notes. Okay, so Andy should be able to sort you out there. So back onto the course. So we're just talking about how to change the code cell from command mode to code mode. So the next thing about the advantage of using Lab notebooks is that you can add actual textual description to your code, and then you can format it in a way that makes it more readable. And so these are things that you can do. And this will be automatically interpreted. So in a code cell, you can do something like this, for example. You can just make a list, or you can indent things, or you can enlarge the font so that it appears as a font size that's consistent with a header or a title. I'll just show you what I mean. So if I do the same thing, I start to type some markdown, and I just say this item 1, and I put return, and this item 2, and another item. And when you've done that, and you've typed some text into the code cell, if you just do a very small keyboard call, if you press the Enter key with the Shift key, you can see, oh, I've got I think what I've done here. Yeah, that's the thing I forgot to do. So that's an error. Yeah, thanks. I just saw it was in code. I need to have it in Markdown. That's what I need to do. So now if I press Shift and Enter, that runs that code. So what's that's done is that's formatted that text according to the Markdown instructions that I used, or the Markdown notation. And I can go back to it and change it again if I want to. So if we look at some of the other things you can do, if I want to do a header, for example, I can just do this, and my header, and then if I want to run again, I said you can just press the Shift and Enter key at the same time. That's the easiest way to do it. But I can also click on this arrow here to says run the selected cells, and you can see I've got my header part is in a larger font. So the way this kind of is useful, and then it can go well with the Python code that you are writing. Again, as you write a piece of Python or a long section of Python, you can intersperse it with Markdown notes, and so something like this might will tell a reader what the code is, the purpose of the code is, and what it does, and it's in a nicely formatted way that's easy to read. I mean, normally in code, a comment that's added is just in a flat sort of format, And so by eye, it can often sometimes be hard to separate from the raw code. But being able to control the format like this makes it more of a readable. So I think there's an exercise here, which is to create a nested list in a markdown cell in a notebook that looks like that. So if you can try that exercise, just to create a markdown, so the key thing to do is to make sure here that you've got the markdown selected and not code. You can go back to raw to see how it is, and then when you've typed it, when you've added your markdown notation, you can then go to markdown, and then you can run it. So if you just do that exercise, if anyone has any issues or things don't display as expected, you just raise your hand or post a question in the chat. So I'll just wait a minute or two for people to do this, and I'll go back to the windows so you can see what the exercise is. I see that Andy has come back into the main room. Is everything okay now? Are you able to get a Jupyter Lab interface up, and you can now get a notebook and go into a code cell? Okay.
Yes.
So I'll just go through this exercise. So you've got a code cell here that, I mean, at first by default it will be in code mode, and you can type in some what's known as markdown. There's basically text which has some particular annotation characters that you can add. So you can have a hash character to indicate that the text that follows should be in a header-sized font. You can have an asterisk to indicate that the text will be part of a bullet list. But as you have to indicate that this is going to be markdown. And then when you've done that, you can run that bit of markdown script to render the text that's in this markdown cell. A number of ways you can do it. You can do a run you can select the option in the menu here. You can click on the run icon, this right arrow, or you could just press on the keyboard if you press shift and enter at the same time, and you run things, and you render the markdown text, and that's what you see. So there was an exercise here for us to do. If I can just do that briefly, I can maybe cheat a bit and just copy things across into my cell window. So that was, I think there was something like this. One, oops, two, and then I have to indent it. I think that was 3 indentations. And now make sure that's marked down. And there you go. That was quite straightforward. So that's that. I don't think there was anything. So I assume that everyone was happy in doing this. So now we're going to do some actual code. So this is just a very simple exercise to go back to one of your, to go to a cell, to keep it as a code cell, and to just do some maths, basically, and you just do basic, well, arithmetic, I say. And again, just you do a run, and then it will output the results. And so that's just to get familiar with things. So I think it's kind of obvious what's going to be displayed. When you do that, you're going to see 21 and 3. Yeah, so there was a 3 times 7 and 2 plus 1. So there's a point that's been made in that exercise, in that what is displayed is actually the last calculation that's done in the previous code cell. It doesn't display both the calculations, only the last one. And then you can do something that's a little more advanced. You just declare a variable, and then you can print it. And it's saying, it's just asking you to experiment with this and to take this and try to run that within a markdown cell as a markdown, and that will display, I think. But I mean, obviously, it's going to display it in a way in that it's going to ignore line breaks. You can go back to it as it was, and then if you run that as code, you get what you would expect. 6 times 7 is 42. That's 12. 54. And then there are some other things you can do, more advanced things you can do in the markdown cell. I mean, normally it's the case that within your implementation of Python, you'll be implementing some kind of mathematical equation, but you'll be constrained, obviously, to use the syntax of Python. So sometimes it can be not so obvious what the maths is that you're trying to code within Python. So you can use a markdown comment to actually make it clear. You can format it really nicely so that you can do things like you can format a mathematical equation so you have subscripts and superscripts and so on. This is just an example here. So I have to make sure that it's marked down. And there you go. This is like a sigma. This is you're doing a sum and so on. Just shows you how to use Greek symbols, and also then how to annotate them with superscripts and subscripts. Just check there's the chat there. So finally, there's how to close Dupli, and that's kind of a simple thing. So from the file menu, you can just select shut down, which is down here, and then you'll be prompted to confirm that you wish to shut down, and so on. That's really, and then you restart the Dupli server either from a command line in the terminal shell, or you can go back to your Anaconda interface if you have one, and launch a Dupli UI as a tab in your browser. So that's the end of that section. I don't know, I'll just give people a minute to practice, if you haven't done so already, just to practice closing down your Dupli server and start again. Is there a keyboard shortcut to switch from Markdown to code? I don't know in my head. I would have to look that one up if there is one. I don't know if Andy knows. So thanks, Justin. Someone's just helpfully posted a link there that says how to do that. Escape, then M here. Yeah, so what we're doing is if I highlight a code cell and click on escape, I guess C M changes to Markdown, C. So let's see if I can. So I don't know what it is to go into code for Markdown. I wonder if we can do raw. Yeah, so R is for raw. I'm not sure what the code. Go back into Markdown. Ah, right. Yeah. Thanks again. So that's. Yes. So there are shortcuts for changing whether or not your cell is code, Markdown, or raw text. Okay, so I'll go on to the next part. I'll just pause for a moment and just ask everyone just to check that everyone was okay with that section. Everyone is able to use Jupyter Lab okay. I think that's the case. So we'll now move on to the next part, which is variables and assignment. So variables are simply names for values, or that's like a label. And so in Python, you'll use the equal sign to assign a value on the right to the name on the left. And so we've got a simple example here where we have age is being assigned a value of 42. And then we have another variable called first underscore name, and it's been assigned a value of Ahmed. But you'll notice that these values have an implicit type. 42 is a number or an integer, and Ahmed is a string containing 5 characters. But there's a bit of information on the restrictions, or what variable names can contain. So you can contain letters, digits, and underscore, but you cannot start with a digit. It's also case sensitive. And general, within Python, variable names that start with a double underscore normally have a special meaning. So we won't talk about that just yet, until a bit later on. We'll talk about what the convention is when you have a leading double underscore. But with these variables, once you've assigned a variable, a value to a variable, you can then print them. So there's just a very simple built-in function called print. And so we had those two variables called first name and age, and you can simply build them into a string that you pass into print. So we're passing print here is a built-in function, and we're passing it a number of parameters. One is the variable first name, which is a string. One is a string that we're setting up on the fly, as it were. We're not actually assigning it to a variable. And then there's the integer variable age, and then there's another a temporary string. And what print will do is it will take those those 4 parts, and just format them. It will just separate them using spaces, and then you have the output. Ahmed is 42 years old. And then if you did another print statement after this, you would find that the second print would go on a new line. So before you use a variable, it must be created, and by that means you must have assigned it a value. You don't have to declare a variable as such within Python, because when you declare a variable, that's when you define what its type is going to be. That's when you define what type of values that variable will be able to hold. But the type is implicit, it's decided by the value that you first assign to the variable. And you can see here, you can just declare things if you didn't declare last name, or if you didn't initialize last name, by which is an implicit declaration of that variable, you would get this error if you tried to use a variable before it being defined. There's a wee bit of a slight bug in the software carpentry script. I think this link here, which is telling you about error messages, is a broken link. It's going to the wrong page. It takes you back to the schedule, but where that should be taking you to is instead of 15 hyphen scope, it should have been 17 variable scope. And there's a part, I mean, this is an exercise that we'll go through in the afternoon, but this part is about understanding an error message in more detail. So that's just a small error in the course material. Moving on from there, so the value of a variable will persist between cells, and that the order of execution is important. So so here the my val equals 1 will need to be executed before you print my val. And what the Python Dupli Lab is a notebook environment will do, it will remember all code that was run previously, including any variables you have defined, and that is irrespective of the order in the notebook. So if you define variables lower down, and then you run cells further up, those defined further down will still be active. And so really though, just to be clear, any variable that you use should have been defined or initialized before you use it, just so it's clear to the reader. But there is a way of being able to, if things are a bit confused and you're not sure what state things are in, you can restart and run it all. And that's just from the kernel here. Restart and run themselves. So variables can also be used in a calculation. So you can declare something called age, and then you can add 3 to it. And if you do that, you should get 45 if it was defined as 42 initially, as per the example. So an integer variable can easily just be incorporated into any kind of into a math expression that uses multiply, divide, or subtract, and so on. With string variables, you can do some manipulation. You can extract individual characters and so on, and you can use this kind of notation where you use a square bracket, and then you put the index value inside there. So this is an example that's shown here. I'll just do that here. So I've got a string. The value is helium, and what I've done there is I've just accessed the 0th element in that string, which will be H. It will be the first one. And then you can do things that are a little more advanced. You can do slicing. So that's where you can extract a substring. Is there any way that after you write a variable, then you can edit it anymore, like a constant? So, are you saying that you want to declare a variable and you don't want to change it? Not sure that there is. I think normally you would just have to use a convention, like a variable name convention. So you have to say if something is in capitals, then that is implicitly a constant. But I'm not sure. There are object types within Python that are immutable. Immutable mean you can't. Yeah, yeah. So what Andrew's saying is right. Is that Python does not support constants. So I'm afraid it would have to be. You would have to, if you were looking at the code and it was code that you were going to maybe come back to it, you maybe have to set up a convention that if something's all in, you know, if you've used uppercase for a variable name, then that's indicating that that's a constant. And if it was called, I mean, if the name of the variable was plank, or plank underscore constant, and how do you know that you're not overwriting something? So are you saying that if you declared a variable at one point and then you may have changed it later? But the only way is to do a kind of a print. You can always print the variable to see if it's the value that you expect. Yeah, that's what I say. Yeah, you've got. Yeah, it's up to the coder to be careful. You can do things like asserts. So if you were worried that a variable might have changed, you can add in assert command to say that this variable must have this value. And then when you run it later, if that assert is broken, that'll be flagged up as an error. I think asserts do come up at a later stage in the course. So I think we can show some examples of that later. So now, just to get back to strings, we're talking about substrings and how to do slicing. And what you do, you use the square bracket notation again, as shown here. And you to do a slice, you specify a starting point and an end point. And the thing you have to remember is that the starting point is the actual starting point. So you're starting at position 0, so it includes position 0, which is S in this example, the sodium. But you go up to 1 before the end. So the endpoint being 3, you actually go up to index position 2. So S is at 0, O is at 1, D is at 2. So what gets displayed is the first 3 characters. And so that's what you have to remember. The maximum bound is exclusive, if you like. That position 3 is not actually included. So this means that, I mean, there's a built-in function for strings that you'll see quite a lot called len, L-E-N. And you might have something like this. So you might do len to name. You can just run that. Whoops. That's 6 characters, and then you could same thing here. Sometimes that's fine because you're only going in terms of the character positions that you're indicating in this slicing. You're not going up to character 6, which, you know, the character at position 6, which doesn't exist because M exists at position 5. That's 1 before the length of the string. So if you did do take 6, for example, it could still be fine actually, because it only does as much as it can do. It won't go any further if it realizes that, you know, if the string is only 6 characters, it will then it will try and fulfill that request as best as it can. But that's the thing to remember with slicing, is that the maximum bound, you don't go, it's not inclusive of the maximum bound. It only goes up to one before. And it means also that the if you want to work out the slice's length, you can do the stop minus the start. So it'd be like 6 minus 0 in this example here. Taking a slice does not change the contents of the original string. What taking a slice does is it returns a copy of that part of the string. And here's some notes about using the built-in function len, which I've already just touched on. Mentioning here that Python is case sensitive, so a variable like name, where the first letter is uppercase, will be different from a variable also called name, but all the characters are lowercase. And there are conventions for using uppercase letters at the start of variable names. Normally in Python, you can have variables, you can have functions, and then the next level of software abstraction is something called a class. And a class will be a group of functions or methods. Methods and attributes. And attributes are variables, and methods are functions, but they're encapsulated and associated with a particular class. And so a class name would typically start, its first letter would be in capitals, but the first letter of variable names normally would be lowercase, and also for function names too. It depends on your convention really. So Python obviously doesn't care about the names you actually use. It's just up to the programmer to make sure that the names make sense in the context of the program. So if you're using random names like flabadab or EWR, blah, you know, it might be clear where you're at the part of code where the value is being assigned. You might think, oh, that's obviously a string, that's obviously someone's name. But if you imagine that your Python code is lines and lines long, if you scroll down a bit further, so that where flabadab is being assigned is outside of your screen, when you look at flabadab just on its own, you'll be a bit confused about what it actually does. It's the kind of extreme example. So try to use names that are intuitive, that will tell you what this variable is doing in the context of the Python code. And now here's an example, here's an exercise to do, where you'll go to your Dupli notebook and you'll start a code cell, and then you'll just type in these assignment statements, and then the point of it is to be able to fill out this table, and you're using the hash symbol in order to indicate a comment. So what comes after the hash symbol isn't code, it's not executed, it's just a comment that will tell you what's going on that line of code. So if you can just fill this out, so that the first one, for example, what is the value of x at this point? Well, it's 1.0. What's the value of y? Well, it's not been defined yet, so it's going to be defined in the next line. So you would say it's not defined. And also swap isn't defined yet either. So if you go through those statements and you type them into a code cell, and I'll leave you to do that exercise. If anyone is not clear about what to do, just raise your hand or post a question in the chat. Okay, has everyone been able to do that exercise? Is there anyone who's having any problems? Because I'll just show the solution. So I think it's quite clear. So for the first statement, where you assign a value 1.0, a float rather than an integer, to x, well, only the x variable will have a value defined. And then the next line, y is assigned 3.0. The next line, swap is given the value of x, which is 1.0. And then x is given the value of y, which is 3.0. And finally, y is given the value of swap. So y loses its 3.0 and gets 1.0. So we're exchanging the values of x and y. Okay. I see that there's someone, Baris, I hope I'm pronouncing your name correctly. So what's the problem with the swap exercise? Where does it go wrong for you? Could I implement Reducer, please? Okay. So I'm in my Jupyter Lab notebook. Is that what you mean? So we have something like this. Yeah. So I do x equals 1, and then I can do y equals 3.0. So what I want to do is swap the values. So I do swap equals, swap equals x. So swap is equal to x. So each time I'm doing a code cell, and then I just press the shift and the turn key to actually run that cell. So at this point, x has the value 1.0, y has the value 3.0. And then swap is like that. And now I can do x is equal to y, and I run that. And then I do y is equal to swap. I do that. If I wanted to just find out, well, what's x and what's y? Yeah, you can put the print option, but if you just want to type in x, it will do that. So you can see that x has y's value, what was originally y's value, and y, I'm just doing a cell run here, has x value, has x initial value. Okay, that's fine. So the next, something else here, predicting values. What is the value of position in the program below? Try to predict the value without running the program. So we have initial is assigned the value left, the string left, and then that initial string, if you like, what initial is pointing to is assigned to something called position, and then initial is changed. It's given another string, right. So what will be the value of position? It's either going to be left or right. So what do people think it's going to be? Yep, they've got one answer. I mean, it's quite simple. Yes, left. Because the next time you assign a string to initial, that's a new object effectively. But the old object, the left string, still exists because there's a variable position that's pointing to it. Yeah. And there's another exercise here. If you assign A the value 1, 2, 3, what happens if you try to get the second digit of A via A square bracket 1 close square bracket? So that's quite an easy one. So the thing here, this is an integer, not a string. So you're trying to do a string operation on an integer, and get a type error because an int object is not subscriptable. But if you declared 1, 2, 3 as a string, as you're doing here, then it's valid to ask for the character at position 1, which is the second character, because in Python we have 0-based arrays. So we have something about about choosing a name, which is a better variable name, m or min or minutes, and this is the code which you're trying to use. So you've got 2 examples of what's the best thing, or you may have your own ideas. So you've got a very terse example, it's example 1, where you've just got variable names are single characters. Example 2 is a bit less terse, and then example 3 is maybe a bit too verbose, perhaps. The idea of thinking what would work is imagine that you've written maybe a 200 or 100 line Python script, and then in the middle of it you've got a line like this, or maybe it's like that, and then you're going to come to it and you're not going to read your code again from the first line, but you're going to dive into your code and you're going to go to that part of it. You know, how confident do you think you'll be that in like 2 months' time, when you look at that individual line, you'll be able to understand what's going on? So what do people think? If people can just either indicate a preference by just typing a number, 1, 2, or 3 in the chat, or maybe just putting their own statement in. Three, yeah. Or 2, okay. The point, I think, about 1 is it's maybe a bit too terse. With 2, there is a bit of a problem with using min as an abbreviation for minutes, because min is often used as abbreviation for minimum. So that might be confusing. Sec is unlikely to be confused with anything else, although I'm not sure. I think you might be able to have a hybrid between 2 and 3, but yeah, that's what it makes a point about. Minutes is better than min. So I mean, 3 is okay. If you had to choose one of those 3 examples, 3 is the one to go for. 2, okay, you have to be a bit careful about the confusion over min is a bit ambiguous. So here's another quick one. What does the following program print? You've got atom name equals carbon, and then you're printing a slice, and you're going to be which letters are going to be output. Can anyone say? Yeah, that's correct. I think it's quite a simple one. Oh, sorry, say ARP. I typed in. It's obviously 1 before. So it's position 1 and 2, not 3, because the maximum bound is exclusive. The minimum bound is inclusive, so you start at position 1. So it's 0, 1, 2, 3. So you go from 1 to 2, but not to 3. So it is AR. Yeah. So that may be a good exercise, because I can just catch out that the minimum bound isn't to be interpreted in quite the same way as the maximum. So you've got a few more now. I think if you can get through this, you will understand slicing quite well. So I think after we've done this, we'll have a 10-minute break. And then I'm anticipating that we'll start lunch at 1 o'clock. We'll have lunch between 1 and 2, so I hope that's okay for everyone. And so just before we have the break, if we can go through this exercise. So we've got a species name. I'm not sure what that is, whether it's, I guess it's flora, some Archaea, it gives it away, Doxifolia. And you've got a number of exercises, a number of different slices being made, and then you have to say, you know, what part of that string is going to be returned. And of course, you can quite just copy each of these slices into a code cell in a Jupyter Lab notebook, assuming that you've copy and pasted this one first, of course, and then you can just see what gets returned when you run each of the code cells that has each of these. But probably be better if you do it before you try and just run things within the Python notebook to see if what you think is what actually happens. So I'll just give you a couple of minutes to do that, and then we'll talk about any gotchas within this. And then we'll have that break. Okay, so you might have had a go at this. I'll go through each of these examples. I'll just show the solution. So the first thing is that this character, this string contains 16 characters. So when you go from 2 to 8, well, 0, 1, 2, so you start from position 2, which is the A, and then you go up to character position 7, 0, 1, 2, 3, 4, 5, 6, 7, so that's the B, so that's just one before 8. And then 11, so you're starting at character position 11, which is the F, and then you just run until the end. That's what that means when you don't have anything after the colon. So you don't actually specify a maximum bound. If you go the other way and you don't specify a minimum bound, then that's just going to start from position 0, and so that's the first 4 characters, position 0, 1, 2, and 3. If you just put in a colon and don't specify either a minimum or maximum, you just get the whole string returned. So example 5 is a bit is something new in that we're using a negative index value. So in Python, if you specify -1, that means the character at the last position in the string. So when you go to -3, you actually go back, you look at the string, you can think of that's -1, that's -2, that's -3, L is -3. So you're going from position 11, which we know is F from the L example, up to the position that is 1 before -3, -3 being the L. So you just see F and 0. And then it's the same thing if you do -5 and -3, because -5 is basically the same position as position 11. So just, you know, if you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or you can do -1, -2, -3, -4, -5, for F. And then when part of the slice is out of range, the operation does not fail. It will give, I mean, in those examples that were shown there, it will give the same results as just the entire string, basically. So it will try and get as many characters as it can. So I think we'll have a 10-minute break. If there are any questions about what's been covered so far, if you just raise your hand or just type something in the chat. That if everything's okay, I'll give everyone a 10-minute break to go away and have a drink or whatever, and we'll come back at 11:45. Okay, hello everyone. So I hope everyone's back from their break. So the next part is data types and type conversion. So we've already declared some variables, but we're going to look at a bit more about the types of values that you will assign. So there is a built-in type, say a built-in function called type, to find the type of a value. And here are some example code that demonstrates how you would pass, say, the literal value 52 to type, and that will tell you it's an integer. If you assigned a string to a variable called fitness and then asked what is the type of fitness, it will say it's a string. Now, what type a variable is, basically that controls what operations you can do on that variable. So if it's an integer, you can do arithmetic. So you can do subtraction. But if you try to do a subtraction using strings, that's not going to work. It's going to, you have a type error, unsupported operand. So the subtraction operand is not supported for strings. You might think it should be. Really, you think it's kind of it's not totally non-intuitive, because you would think that that statement would mean remove the letter H from the string hello. But you will know from a previous, from the last part, you can just do slicing. So you could assign hello to a variable, and then you could do a slice on it, where you would have what you'd have inside the square brackets would be 1 colon, and then you'd leave the maximum bound empty, and that would have a similar effect. But no, in general, that's not allowed, just to do like almost as if it's an arithmetic subtraction. You can use the plus operator on strings though, and you can use the multiply operator too. So the plus operator is essentially acting as an append. So I've got my full name variable, and I'm assigning Ahmed, and then I'm appending a very short string with just the space character, and then after that I'm appending the surname. So that's fine. And then the multiplication is used to replicate the string effectively. So this example is showing the variable separator, which contains just one character. And if I have multiply 10, it will then form a new string that contains 10 equal signs. But I could do that with any size string. So if I had 2 equal signs in there, I'd have 20 equal signs. Strings have a length, which you can get using the built-in function called len. Talked about that previously, but obviously that only works with strings, not with numbers. So if you tried that with an integer, you get an error. The object type has no len function. You can easily convert between numbers and strings, but you have to be careful to do it explicitly. So here we've got an example. We're doing a print 1 plus the string that contains the digit 2. So you can't combine them using the plus when one's an integer and one's a string. So you either need to make them both integers, which is what's done here. So you're parsing that string to turn it into a 2, or you have to make the other one a string. And you can see that the meaning is different. If I make them both integers, then the result is 3, the number 3. And if I make them both strings, then the result is well, it's a string that contains the digits 1 and 2, or 12. Generally, you can mix integers and floats quite freely, and the result will be promoted such that you don't lose any information or any precision. So when you do this, what is a half? 1 divided by 2.0, that's your float. The denominator is your float, and the numerator is your integer. The result will be a float, 0.5. And even when you could express the result as an integer, it's still going to be a float. The 3 squared is 9.0. Variables only change when something is assigned to them. So if one cell in the spreadsheet depends on another, you update the latter, the format updates automatically. This doesn't. And when I talk about spreadsheet, I talk about an Excel spreadsheet, like a Microsoft Excel. But this won't happen in programming languages automatically. Here's an example that shows it. So if I have variable 1, it's set to 1. Variable 2, that's set to 5 times 1, which is 5. If I then change variable 1 to 2, it doesn't then update variable 2, because variable 2 just remains as it is. So that will remain as 5. So it's not the same as the behavior that you would see in a Microsoft Excel spreadsheet. So there's a short, simple question. What type of value is 3.4? Well, how can you find out? I'll give you the answer. You can pass 3.4 to the built-in type function. It's a float. There you go. What type of value is 3.25 plus 4? Well, it will be a float. There you go. 7.25. And now I'll leave you to do this exercise. So this is again thinking about what choice you would make. So what type of value, integer, floating point, or character string, would you use to represent each of the following? So these are like attributes or variables that you use to describe the text or the data that you're trying to manipulate. So you decide, say, for the first one, what type would you use to hold the number of days since the start of the year? What type of variable would you use for the time that's elapsed from the start of the year until now in days? So I'll give you a minute to look through those. I'll tell you what, if anyone says they're not sure about anything, if you're not sure about any of these 6 examples, if you just post that in the chat and we can discuss it. But it's either, you've either got a choice of an integer, a floating point number, or a string. Okay, so I'll go through them. So for the number of days is an integer, because the number of years, the number of days in a year is always a whole number. The time elapsed from the start of the year until 9 days, so it's going to have a fractional part, so that'll be floating point. Serial number, the serial number is likely to be a text if it contains digits and letters, and then you do. A lab specimen's age, well, that really depends. You'd need more information, what units you're using. The current population of a city would depend on the units too. If it's individuals, if you're counting at the finest scale possible, then an integer. But if it's number of millions of individuals, then that's likely to have a fractional. That will have a fractional part, and so that will be a float. And then the average is quite likely to be float. That will have a fractional part. Moving on to something that you might not be too familiar with, division types. There's two. There's one that will do a floating point divide, or give you a floating point result, and there's another one which is called whole number floor division, which will give you, which will like round down to the next whole number. So when you divide, you do 5 //3, you're using the floor division. So you take 1.667. What's the whole number below that? It's 1, so you get the result 1. And 5 ampersand 2 is giving you the remainder. So it gives you the whole number result as well. So there's an exercise here where if the number of subjects, it's a number of subjects taking part in the study, and you have a number per survey, is a number that can take part in a single survey. Write an expression that calculates the number of surveys needed to reach everyone once. Tell you what, as we are running a bit short on time, I'll just go through this one for you. So what we can do is, if you declare your number of subjects as 600, and the number per survey that you can have, the number of subjects per survey is 42, you need to work out the number of surveys that are required. So you need to avoid having fractional parts. So you subtract 1 from the number of subjects, and you do a floor division using the number per survey, and then you need to add 1, and that will give you the number of surveys required. So you require 15. So that's just, as we're running short of time, so that just gives you an example of when you would use the floor divide, because you can only have a whole number of surveys. Moving on from there, from strings to numbers, so you can easily you can convert from a string that contains a floating point number just using the float, and then you can convert the float to an integer, and that's done there. So in some cases it might not make sense. If you try and convert hello world to a float, that's not going to make sense. And got an example here where you're trying to convert a fractional string to an int. And if you try that, I think I'll ask you to, if you try that in a code cell, and what do you see? I thing that you get is an error because it's expecting that to already be an integer, and it's not. So you'll need to first convert it into a float, and then you can convert it into an integer to get 3. So I just show you there's something else that you would need to be aware of. Or if I have a number, say, I'll call it my float, and it's equal to 3.6. I wanted to convert that into an integer. I can do my int equals round 3.6. That's displayed 4. So that what that's done is that's automatically. I'm just saying that there is a rounding function because sometimes you wouldn't want to just go to. If I did, if I change that to an int, it would just that would become a 3. So that you might want to do something. You might want to round up to the nearest integer, so that you can then use this this function here called round, and you can also this round function, built-in function, takes a second parameter, which is the number of significant places that you can round to. So I might have, say, 3, and if I have, I don't know, that. Hold on a second. That would then, if I do that, that would then need to be a float. I'm just going to print my float 2. That's rounded to the third one, which is 8, which really means that 7 becomes an 8. But I've changed that for 1, and I go 3.7 instead. So I'm rounding to 1 significant figure, or I could do 0, which is the default setting for the number of 4. So I just thought you show you that. That's useful to slot in there. Going back to the course notes. So which of the following will return the floating point number 2.0? So you've got some initial setup here where I'm assigning values to 3 variables, first, second, and third. First one is 1.0, and the second is a string, and the third is a string. So which of these returns 2.0? I'll give you a minute to do that. Okay. I'll just check. Is everyone okay so far? Is everyone having any issues, any questions they need to raise? Okay, that's good. So the answer to this is, well, let's look at the first one. So first is 1.0, and second is the string 1. So that's okay, actually, to convert that to a float, because that will be 1.0. And so 1.0 plus 1.0 is 2.0. So that 1, give a tick for that one. Float. So the next one we do a float return 1, 1.0. So a float of second is 1.0. A float of third is 1.1. That's going to be 2.1. So across there, that doesn't match. First is 1.0. And int of third would be 1.
Sorry, that's going to throw an error because it's not an integer. But 4 would work, I think. 1.0. So yes, so that's correcting 3, and I think both 5 and 6 don't work. They don't return 2.0. So second is 1, 2 times, so that's going to be 2.0. What's it say? 1 and 4. Yeah, because 2.0 times second won't work because you're multiplying 2.0 by 3. So even on to complex numbers. So complex number can be written as this. So you can have 1.0 plus 2.0j. J indicates the imaginary part. And then once you've assigned that to a value, you can then access the real and the imaginary parts like so, as is shown here, and you get this output. And then you have there's a question here about why do you think Python uses j instead of I for the imaginary part? But I think that's just, I mean, I'll answer this one. It's just for historical reasons. I think j is typically used in an electrical engineering context to indicate imaginary parts, complex numbers, and it just stuck. That's just for historical reasons. That's what's used for Python, and I guess also maybe I is a very common variable for indexing arrays. It's usually the array it's like the counter variable used to iterate through a loop. So that may be another reason. What do you expect 1 plus 2j plus 3 to produce? So that, I think that's going to be 4. What does that say? Let's look. 4 plus 2j, yeah. And then what do you expect 4j to be? Well, that's just a complex number that only has an imaginary component. But 4j or 4 plus j will cause syntax errors because the Python interpreter will be thinking that j is actually a variable rather than a suffix that denotes that the number preceding is an imaginary part of the complex number. So that's data types and type conversions. You can now go on to built-in functions and help. Is everyone okay with complex numbers? That was quite a short section. But I guess everyone is. So we'll talk about functions now and how to specify them. So there's just a bit here about how you can use comments to add documentation to programs using hash, which I think I talked about when we were talking about Markdown at the start. Now a function may take 0 or more arguments. We've seen a few functions already, such as len and type, and also ones like type conversion functions like int and struct and float. And there's also print too. Print with no arguments just prints a blank line. So I think you should always use parentheses, that means an open bracket, closed bracket, after the function call. Yeah, that's right. Or you can, I've seen the comment from Andrew Turner in the chat. Or we can use 4j. So that's 2 examples of calling the 3 examples of calling the print function. So yeah, if you always have parentheses afterwards, then to the casual reader, it's clear that that's a function and not a variable name. So every function call produces a result, and even if you don't, I mean, when you define a function, you can normally return a result using the return keyword. But even if you don't do that, it will return a special result called none, which is indicated here. So none is a Python object that stands in any time there is no value. So when you do a print, it doesn't return a value because it causes a side effect, if you like. It prints it prints example, but what it returns, none. There are some commonly used built-in functions, such as min for minimum, and round, which I showed you earlier. And so min can do things on. You can pass it any number of parameters, and it will return you the numerical minimum, or here you could use max to return you the numerical maximum, which is 3. You can do the same thing with strings, actually, but with not strings, with single characters. I think also with strings too, because you can do a comparison using ASCII codes. So here the digit 0 has the a lower ASCII code compared to uppercase A or lowercase a. They're saying also that functions only work with certain combinations of arguments. So things that can be meaningfully compared, you can't meaningfully compare a string with the integer 1 when you're calling maximum. So you get an error there. So it can't compare them. It can't work out which one is greater than the other in order to decide which one is maximum. Functions may have default values for some arguments. Okay, so I should get my terminology. A parameter, I think of parameters, variables that you pass into functions, but I'll refer to them as arguments from now on. So round, I showed you earlier, will round off a floating point number by default to 0 decimal places, but if you pass it 1, it will round to 1 decimal place. See there. Now, yeah, functions can be attached to objects, and you will first encounter them as attached to string objects. So you can do things like you can declare a string hello world, and then you can swap the case, which will change uppercase letters to lowercase and vice versa. Or you can actually find the string using a built-in function. And this is where you see an example of a function name being preceded or surrounded by double underscores to indicate that it's a method function that's been declared for a string class. You see examples there. And there are other methods, a method being a function that's attached to a string object. So you've got one for saying, is this in uppercase? So this returns a Boolean that evaluates to true if all the letters are uppercase. My string upper, that actually changes the letters in the string, that capitalizes them all. And this one should return true. So it's important to point out that I think my string upper is creating a new string. And then I'll explain what I mean here. So if I were to start with you. So if I have my string and it's hello world, and I say my string is return false, but then if I was to do my string I'd say is, will return true, but if I then did my string, that still as it was. What actually happened was that my string.upper returned a temporary string variable, and I was running isUpper on that temporary string, and that was a copy of Maestro, and so that's why Maestro actually still retains its original value. So for any function, this is quite useful. For a built-in function, you can pass it to help to find out the details. So for rounds, you can find some help where it tells you the number of arguments that function takes and what those arguments do. So it's the actual number itself that you want to round, and then the number of digits that you want to round to, and it tells you what the value returned is. So the Jupyter Notebook has two ways to get help. You can place the cursor near where the function is invoked in the cell, and you can hold down Shift and press Tab, and then you can expand the information returned, or you can type the function name in a cell with a question mark after it. So let's do two examples of that. So if I have this, do Shift and Tab. If I do round, because I had the wrong person key. Shift and Tab. There you go. And now you can tab. Trying to do it the right way. Shift and tab. It's not quite working. Maybe on that string. Shift and tab. Then okay. Maybe question mark. No. I think I've got that. But if you want to find out about len, I can do this. That tells me about len. If I want to find out about isUpper, I can do the Maestro. And that can tell you about all the functions that the string object supports. So we've got isUpper is among the list. I think we can do that, yeah, so you can do that to get the actual help. So I'm not sure about those things there, so just ignore those, but there are alternatives to get help for particular functions that you need. So Python reports a syntax error when it can't understand the source of the code. So here you're attempting to declare a string variable, but you've not put in the closing quote so that it's clear that it's a string. Here you've just done a syntax error where you put in 2 equal signs, invalid. And there you try to do print hello world, but you've not passed the closing parentheses there. You'll always get an error message, so you at least know the line of code that's causing the problem, and the error message itself would be quite clear. It will point to exactly where the problem is. So when you run a program too, so if there isn't a problem with the syntax, so when you're typing in your code, it's syntactically correct, then you'll be able to do that without seeing an error. But then you may see an error when you come to run it. And this example here, the problem is simply that you've mistyped the age variable. You put in an extra e, and then it will just tell you that this other variable, aege, is not defined. So that's quite clear. Here's an example here, which I'll leave you to have a go at. So explain in simple terms the order of operations in the following program. When does the addition happen? When does the subtraction happen? When is each function called, etc.? And what is the final value of radians? So if you can just post, once you've worked it out, you just post in the chat what the final value is. So you need to know something about which order arithmetic operations are normally done in. So the multiplication will usually be done before subtraction and addition. So anyway, I'll just give you a minute to do this. Okay. Does anyone have any answers yet? Yeah, that's correct. 2.6. So we have 1.1 times radians. That's the one that's done first of all. So that's just 1.1 because radians are 1.0. 1.1 minus 0.5. That's the next one. Will be 0.6. And so what's the minimum of 1.0 and 0.6? 0.6. So 2.0 plus 0.6, 2.6, and so on. So the next one is just to so predict what each of the print statements in the program will print, and does max, len rich, and then poor. Does that run or does it produce an error message? So I can, you just work out what the last print statement will do, and just post answers in the chat again. Okay, so yeah. So if you look at the last one, that last statement, does anyone know what the answer is? I'll go through it then. So the length of poor, I mean, this is an example of confusing variable names, because I mean, in no way does poor relate to tin. I know you can say tin is cheaper than gold. I don't know. So the length of poor would be 3. The length of rich would be 4. So the maximum of 4 and 3 is 4. One of them will return an error. This one will, because you're trying to, if you're trying to compare, so max, rich, and poor. So you can, which one was it saying it was compare? Max, oh yeah, this one. So that, I was looking for that in the actual body. So that's going to return an error because you'll be trying to compare an integer with the actual string. So why is it that max and min do not return none when they are called with no arguments? So you know what do they? Because they will return type errors actually, because the correct number of parameters hasn't been supplied. I suppose if you just return 1, if you had max parentheses 1, close parentheses, that would just return 1. Let's see. So just to check that was expected, but then max. Actually, could be a type error because we don't have anything that's iterable. We've got nothing to compare it against. I thought it might say, oh well, it was okay, so that's fine. And then max with I've never ever called maximum with just one argument because I'd always call it with something that I'm going to compare it with. So, okay, that was useful that I checked that. So even with just one argument, you think maybe you just return one because there's nothing to compare it against. That is the maximum. No, it would still insist that you need to have minimum 2. The next one, last character of a string. So Python starts counting from 0 and then returns the number of characters in the string. What index expression will get the last character in the string name. So that's quite easy to do. There you go. So it's len -1, but I think we've already seen that there are easy ways of doing this. Because when we looked at that Latin name for the flora example, you can just have -1 as the index value to return the last character. Okay. Are there any? Does anyone have any questions about the functions part of the course? Okay, is everyone happy with the pace that I'm moving at? Am I going too slow? I want to go. Okay, so I'll take the silence as everyone's happy with the way things are going so far. No, so I think David's saying I certainly am not going slow. I'm not going too fast though. Okay. Move on to the next part, which is morning coffee, which we've already had. So, okay. So we're now talk about libraries, and there's something when software is grouped into modules, or it's grouped into classes that can form modules, and then you will import a library module, which will then give you access to various classes or the things that are defined within the module. Now there's a higher level of abstraction. So when we're talking about modules and libraries, we're talking about software components. We're talking about standalone software components that are tightly cohesive in that fact that they provide a set of functionality. So I think we've seen that there's a string class, so that provides the sort of methods for manipulating strings. But you'll obviously, if there's other classes, you might have classes for doing plots, or you might have classes for being able to manipulate arrays such that you can automatically do statistics on them. You can do the mean and the mode and the median and things like that. So there's a higher level of abstraction that you may have come across when you are setting up your Python environment, and that's packages. So within Anaconda, you would use something like Conda to install packages, but generally packages are groups of modules, which are then modules themselves are groups of classes. And we've got an example here where we're importing the math library module, and within math we can get the pi constant, not pi. We can then do things. We can then pass pi to a method that's provided by the math library, the cosine function, and that returns minus 1.0, which you expect. You can then do, because you can run help on a single function, you can also run help on the class, on the library module. So, and you'll have a list of things that you can do. So you've got an arc cosine that you can just see, but there'll be a whole lot of things. If you type that in, just do that yourself. Right, I need to import it first. Import math, then help math. And you can see all those things there. All the the versions for functions we currently do degrees and so on, do factorials and exponentials. There are different ways in which you can import things. So you can do something like this. If you wanted to make your code more terse, you might say from math import cos and pi, and you can extend this list however how many things you want to import. And by importing, you can import attributes like the pi constant, or you can import whatever method you like the cos function. So that means then when you come to use cos and pi, things are a little more terse. You're not having to repeat math.cos and math.pi and so on. Makes it a bit easier. You can also then do something that you can declare an alias. So here we do import math as m, and so then we're just referring to things as m.cos and plus m.pi. So that's not as terse as the previous example, but again, in doing this, you'd have to be clear that people understood what m meant. But this is probably quite a standard thing, because you can appreciate the math library module is something that is used a lot in many Python codes. Most people would guess if they saw m dot, and certainly they would guess from what attribute or method you're using that, oh that this is the math library module that you've imported. So there's a quick thing here about there's other things, other library modules that we'll be using later, like matplotlib, which you can aliases mpl, which is fine, which is good. It's unlikely to be confused with anything else. So you have to make sure that when you use aliases, they're not too terse. If it was something that was not a standard library module like math, but your own library module, you probably not a good idea just to give it a single letter alias. Anyway, on to this exercise. What function from the math module can you use to calculate a square root without using SQRT? So I leave you to have a think about that. Okay, so what that relies on is being able to use, if you remember, the help function. So if you ran help math and you scroll down, you'd obviously see that there's a SQRT, square root function, but there's also other functions. There's a POW function, POW function, and so you can raise a number to an exponent of your choice. So if you wanted to do square root, you would choose 0.5. So I think this is just POW is something that was used in other languages. I think it was used in the C standard, so that's why it was included in Python 2. So that's really two ways of doing it. But that was just an exercise just to get you to jog your memory about the usefulness of the help function. And then if you have a library module that you've never come across before, just first of all passing it to the help function can return you a load of information. So the information that you can just quickly scroll through and get the gist of what's going on, or what things that you can do with the class module. So there's this one here in called locating the right module. If you want to select a random character from a string, which standard library module could help you? So probably no, I'll just reveal that. So it's this question about using random, the random module, which allows you to choose a random number within a certain range. So select a random character from the string. So this is what you would do from random. So random is the library module, and then range is a method from there that you're importing, so you can just refer to it directly, and then you work out a random index from 0 up to, but not including, the length of that string, of the basis string. And there's other ways you can do it more compactly, or just using one fewer lines of code. But there's other ways. Again, if you did help random, you can find other ways of doing it. You can take a sample, but you can indicate that you only want to have one member in your sample. That's one way of doing it. And then what sample returns actually is an array. So in this case, it will be an array of length 1. So to get the sample, you'd need to make sure that you've indexed it at position 0. So that's not using sample isn't the best fit. The best fit is actually using choice. So that will automatically just choose one from one letter from the basis string. So the next one, I think I'll give you a couple of minutes to do this, which is rearrange the following statements so that a random DNA base is printed and it's indexed in the string. So that's what you have to do. So you just have to find out what should go into these spaces here for being able to print out. So to print out a random part of this string here. And you also you may need to change the order as well of these statements as well, should indicate. So I'll just give you a minute to do that. This is just to familiarize yourself with the use of random and also of math. Actually, I'm not sure you need math here. Yeah. Okay, so I'll just show what needs to be done there. So we obviously need to n_bases needs to be declared before we call random.randrange, and then we can pass the number of bases to get a random index into the bases array. That's quite straightforward. So here is a quick one. Say a colleague of yours types help math, and they get name math is not defined. What's the issue there? If anyone can just type, it's a simple solution, what the solution is in the chat. Yeah, that's right. They haven't imported math. Yeah. So there's one here to fill in the blanks so that the program below prints 90 degrees. Rewrite the program so that it uses import without as, so you're not going to use an alias. And then it just asks you to, which form do you find easier to read? Okay. So this is what we do here. Is obviously we've used m, we've used the alias m, so we have m.degrees and m.pi, and then we're just printing the angle. What we need to do. So it looks like this, and that's fine. But we could have this import math. Well, it's a bit more terse. I'm so sorry. It's a bit more long-winded in that we have math repeated twice. But when we just import math, then we can. We've not specified what we're actually using. I mean, you could have from math import pi and degrees, and then you could have it like that. So you're not repeating m dot or math dot, and it's going to be quite clear what pi and degrees, what they mean in the context of your code. So this is just the next bit. There are many ways to import libraries, and you can say here, I think what you've been asked to do here is yeah, so that's right, yeah. So there are quite terse conventions that are recognizable, such as when you import pandas, you import pandas as PD, and I would say matplotlib is the same, matplotlib as MPL. So this is just a quick exercise to match up the library import call with the actual statement that you then use. So if you're using sine and pi, you would just have import math for that one. Here you've got m.sine, m.pi, that's import math as pi. Sorry, I made a mistake. So import math would be this one, math.sine, math.pi. From math import asterisk is this one then. Did I make a mistake? It's both of them. It's just back up a bit. So for the first one, if you had done this, that's okay. But also you could have done this, where you import everything that's in the math module library. For this one, it's just this. And for that one, it's just that. Okay. Just check I haven't made. Yeah. Yeah, 104. Okay. So I think this is another easy one, which I'll probably just do. Fill in the blanks so that the program below prints 90 degrees. And it's very similar before. So from math, import degrees and pi. I think. Yeah, that's this one we've just done. Okay, so I see that question there. No, not quite. It's not quite, no. So when you import math, then the attributes and methods defined within the math library module then have to always be prefixed with math.cos, math.sine. But when you do from math import, and it's everything, because you're using asterisk as a wild card, then you don't need to have the math.prefix. So from here, so for example, this bit here, where you see this statement, where I'm using sine and pi directly, I could either do that if I had done from math import sine pi, or if I had done from math import asterisk. Yeah, yeah, thanks Andy, saying the same thing, yeah. So see, if you go down the from math import everything route, then you do run the risk of name clashes potentially. say for something like degrees is a method, but it'd be quite, wouldn't be surprising. You know, it's quite common to have degrees as a variable within your own bespoke Python notebook. So you can have problems there. So sometimes it would be better to always be clear when you're using the math degrees as opposed to your own degrees, be it a variable or a function. We've got one other thing here, another part of math, which is log, to do a log 0, and that's going to give an error, and what type of error will it be? So it's a question to the audience: will it be a type error? It's not going to be a syntax error because you're going to run it. Is it going to be a range error? Is kind of. Well, it's going to be actually. It's going to be a value error. I'll answer it because the logarithm is only defined for positive numbers. Okay. So is everyone okay with that section of the course where we what we did there was we covered library modules and we experimented with importing some of them, mainly math and the random library module, and showed several ways in which you can import library modules. So if everyone's okay, then I'll move on to the next section, and I think we've got enough time to do one more section, and then we'll break for lunch for 1 hour. But I apologise. It does look like we have fallen behind somewhat. But I think fortunately the last section is quite short, very last. So perhaps we'll be able to make up some time. Where other libraries, yeah, we're two sections. But I think the next 2 sections that we'll do after lunch, pandas, data frames, and plotting, are probably the ones that be quite interesting for you. So the next one, reading tabular data into data frames. So I'll just go to that section. So this is where we're going to use the gapminder data, which basically is a set of measurements that record life expectancy against GDP. And we're going to use the pandas Python library for doing statistics on this tabular data. We're going to use data frames. We'll do an import statement such as this, import pandas as PD. And then the first thing we're going to do is read. We're going to use the read_CSV method of the pandas library module to read in comma-separated variable files. So here's an example here. So we import pandas as PD. So Andy's just saying it's his favorite module, his favorite library module, pandas. Is it also named after your favorite animal too? I don't know. So here is what we're doing is we're reading in the Oceana comma-separated variable file, and then it's going to print the data that's returned, and it prints it, and we've got a column for the various times that a measurement was taken. So from 1952, 1957 up to 2007, you can see that these measurements are taken 5 years apart, such that the year in the decade is always the same. So it's always year 2 or year 7 of the decade, if you like, or I should say it's year 3 or year 8, because a decade starts at 0, 1980, and so on. And then there are 2 rows, even though it's Oceania, continentally speaking, it's probably the largest area. There's just Australia and New Zealand in this row. So each country is a row, and each time of measurement is a column. First of all, I think I just check, is everyone able to just quickly do a copy and paste of this code into a code cell in their Jupyter Lab notebook? And does it work? Are they able to actually, does the code find the file? So you can just do, you can select it and type Control-C or Command-C if you're in Mac OS, and then I'll do the same. If you go into here, I'll just launch another. I'll do the same thing, and I'll do a Command-V or Control-V if you're in Windows. And then I'll do Shift and Enter. And then, what's happened? Print data. It took a while there. It took a while to read in that file on the hard disk on my laptop. Is everyone able to do this? If anyone can't, if you just shout. Okay, I think that's all right. That's great. Everyone has been able to set up their Anaconda okay, and then unzip that, the data file and so on. So here's some, if you do have a file not found, which I guess nobody's hitting this problem. So we can go straight onto here. So we're going to use something called index_column, which is an argument that we pass to the read_CSV function to indicate that we're going to label the columns in the data. Oh, I think I got the wrong way around. Yeah, we're going to pass the name of the column as country. So it's these then GDP per cap become the rows. And then we've already seen that, I've already done that. So you can then do data.info, which tells you that there are 2 entries called Australia to New Zealand. And now we've got the data columns, which are as I thought originally. So it's just, okay, so this is just indicating what the types of the values recorded. We've got float 64 bits, 8-bit floats. I think that must mean something else, the data. So anyway, so what this is a data frame with 2 rows named Australia and New Zealand. Okay, so sorry, this argument name is just misleading. I think that must be for historical reasons that that's called that. So what that means is, it's not misleading, it's a column for the names of the countries. So this Australia is a row, and these are also columns also. So sorry about that. I understand. So we can look at the columns variable. We can print that to see the columns that are actually stored in the raw data. And then we can do something called a transpose, which really all that is, you can see that what were the columns now become the rows, and what are the rows become the columns, so on, that's all. And then there's various things you can do. You can do a data describe, which already is just doing a whole bunch of statistics on the various set of measurements. So for the first time, this GDP life expectancy data was collected for the 1952. it's working out, well, what was the mean GDP for all of the countries over all of the continents for that year. Well, hold on a second, because I just remembered what we loaded in was just the Oceania data file. So if this was all instead of Oceania, then that would be the mean for all of the countries, but it's not. If I'm going to be consistent with what the code I've just run, this is just the mean between Australia and New Zealand, and then you've got the standard deviation, and then the mean, and then you've got the 25% percentile boundary, and so on. Yeah, so that's just a comment saying that it will print the statistics as a formatted table. Okay, so I've got a question from Helen. She's not able to find the data file. So, Helen, are you able to see it in the window here on the left-hand side, where you've got a little bit of a tree structure? And you may be able to move around here. You may have a folder here that indicates your home area. And I don't know, it may have been, I take it, have you unzipped the, have you unzipped the Gapminder data? Okay, you have. So if it's open there, if you've got the path, it should be a case of just being able to specify the correct path. I mean, perhaps is it in a folder, in a subfolder called data? Yeah, so I think that might have been what happened. If you just replaced data with a dot, are you then able to read in the data file? Okay. Andy, would you like to take, if you take Helen into a breakout room, and then we can, I'll just carry on with the main notes, unless Helen's been able to do it. Should there be, doesn't work, okay. So what you should see, I mean, if you're expecting it in the current directory that you're in the left-hand side, yeah. Thanks, Andy, if you do that, because I think it might be something straightforward, but we can have a look at it during lunch. So anyway, this is the statistical data that's done for all of the years where a measurement was taken of GDP. And yeah, this is just for the Oceania countries, just Australia and New Zealand. Okay. Andy, can you move Helen into a breakout room? Yeah, I think Andy's just done that. Okay, that's great. So we've got an example here where we read the Gapminder data for the Americas into a variable called Americas and display its summary statistics. So it's basically the same as we've already done. That's fine. And then after reading the data for the Americas, you can use things like Americas.head and Americas.tail to find out what dataframe.head and dataframe.tail will do. So I'll leave you to do this. I'll leave you to import pandas first of all in your code cell, and then to read in the Americas data file. Okay, does anyone have an idea of what would happen if you run Americas.head? So this is after you've read in the gapminder GDP Americas data into a data frame called Americas. So what would Americas.head return? Would you have to call it with an argument? Okay. Just a quick check is no one's having any issues reading in the Americas data, are they? Is everyone okay doing that? Okay. All right, so as we're a bit pushed for time, I'll just talk about this. So what Americas is an alphabetical list of all the countries in North America and Central America and South America. And so ahead gives you the opportunity of specifying that I just want to return, say, the first 3 countries in the list. And tail is the opposite, so it's the last 3 countries. So we can see that happening here. So Americas.head n equals 3. So you get Argentina, Bolivia, and Brazil. And then you will see also the measurements for all of the years that are covered from 1952 to 2007. You can then do the transpose. So then when you run head or tail, what actually will be a head will be, say, the first 3 years in which measurements were taken if you did head n equals 3, for example. Or if it's tail, it will be the last 3 years, or so the most recent 3 years, in other words. So that's what's shown here. So we've done Americas flipped, Americas.t, and then Americas flipped.tail is going to give me the last 3 years of which measurements were done. So now the columns, you'll notice that country is now misnamed. That should be year. So you need to go back into change that. But now on the other columns that we have are just all the countries in the Americas, and there's obviously quite a few of them. It's about 20. And then that's just, we can like flip things back. So we flip, so you can go back. You can do a transpose of the transpose to go back, and we can do the same thing. Instead of declaring America's flipped, we can just have that too. I'll just cover then reading files and other directories. What you would do here is it's all about this path that you pass the read underscore CSV. So that allows you to access the other files that would be your current working directory. And then the last thing is possible to write data, as well as a read underscore CSV function. There's one for writing, and that's when you take a data frame and you convert it into a CSV format. So here's just a quick example of showing you how to do that. So if you have something called process.csv, and then you can just access that and convert it into a CSV file. All to write Americas. So what it's saying is all this work you've done up here, or it may have done when you're changing the ordering or the formatting. You've taken the transpose, and maybe you've only focused on the 3 most recent years that the GDP measurements were taken. You can then take that modified Americas and just put it out to a CSV file that's called process.csv, and that will be in the current working directory within your Jupyter Lab environment. That's quite straightforward, that one. So about time for lunch. Does anyone have any questions about this introduction to pandas? No, so I'm not seeing any responses or anyone with raised hands. So we'll break for lunch and then we'll come back at, oh, so I must, yeah, to repeat this very last bit again. Okay, so the last part was showing that you can use the read_CSV function to read in a CSV formatted file. And we've done that. We've read in the Oceania file and the Americas file. But assuming that then you've taken something like the Americas data frame and then you've cropped it a bit, or you changed it, and by, I say cropped, you've reduced it to just the 3 most recent years of measurements, say, and maybe you're only interested in a few of the countries, not all of them, perhaps just the ones in North America. So you've amended things, and now you just want to save that cut down data frame. You can then do that using a method called to_CSV. And so all that is, you take your the name of your data frame variable, which contains your edited data. Say it's called Americas in this example, and then you call the to_CSV method, and then you just need to pass it the path to the new CSV file, which is being called processed in this example. Is that clear? That part, is that what you meant by the last part? Good, fine. So that's great then. So we'll come back at 2:05, and then we'll get on with how to do plots and things and how to use matplotlib. I'll just say though, if you are still working on any of the exercises, or if you perhaps looked at other material from the parts of the course coming up, just if you have any questions about that, just post those in the chat. I mean, I'll be monitoring things during the lunch hour. I will have my microphone turned off, but I will check if there's anything. No, I was going to start the second. It was going to be at 2:05, not 2:30. Is that okay? Yes, that's right. Oh, okay. Pretty summertime, yeah. Good point. Yeah, I was going to say I will monitor things in the chat, so I will try and respond during the lunch hour if you have anything, or if you come back from lunch early, that's fine.